Hello, in this video I will show you how to use a rigid component. This is the main component which you should use if you want to demolish your object or structures. So first property here is initialization, and there are two ways to initialize objects. First one is by method, second is at start, and by method is default option here because right now if I will start play mode, you can see nothing happens because you should initialize. The object is not initialized yet. And you can do this in editor, you can do this using this initialize button or initialize method. I will show you a bit later. So when I initialize object, it gets all necessary components and become part of the simulation scene, start simulates and can be demolished. If you will set it initialization to at start, obviously it will be initialized at start. But in this case, you can, if you will add rigid component in your code, default property will be by method, so you will be able to change properties first and then initialize in your code when it will be needed. And there are a little script here. I will show you how to use it. You can find it in this tutorial scripts folder. So in this case, I have my initialization to set to by method, and I will add the script to the same object here. And first, I will show you how to initialize this existing widget, which already applied to this object. So here's this line of code. So first of all, you need to get this rigid component using get component, and then in this case I'm setting demolition type to runtime. As you can see, right now it's set to none, and then I'm using this initialize method. So as you can see, even though my initialization is set to by method, when I start play mode, it initializes and demolishes. Also, next way to initialize the object, I can remove my component here. So this time I don't have any rigid component on this object. Now you can see that I'm adding using add component method, and then basically doing the same, change demolition type to runtime, and then initialize object. And another way I will show you how to use. So this time I'm not going to simulate this one. Instead, I will set some other object, geometry, prefab, column. So in this case, you can see that I am first instantiating this prefab, then I'm putting it a specific position, then I add component, change its demolition type to runtime, and then initialize. Of course, you already may have a rigid component on your prefab. In this case, you should use this get component, and then in the same way, you can change properties or use existing properties. But the main part is this initialize method. Here you can see that it all happens. Initiate this prefab, add rigid component, and then initialize so it's get demolished. Next property here's object type, and this is where you can define what exactly you simulate and how exactly it will be demolished, and you should use different types for different structures. First one is mesh, and it should be used for one object with just a mesh filter and mesh renderer, just to see just one object. So when you initialize rigid for this kind of object, it gets its own rigid body, its own mesh collider, and when you demolish this object, it demolishes to separate fragments, separate game objects. Original object was destroyed and it was replaced by these new game objects. Second object type here is MeshRoot, and it should be used for already pre-fragmented object. You can see I have here this time my column already pre-fragmented. So here are all these fragments here. As you can see, they are all children of this root. There are no any deep children, just one layer of children here. So if you have similar object or you already pre-fragmented your object, you can, instead of adding Rayfire Rigid component to every fragment and then changing properties, if you will need to tweak your properties, you will not need to select all these fragments with the rigid component to change. Instead of this, you can have just one rigid component on the root and change properties only once. And when you initialize object with MeshRoot object type. Here you can see that every fragment gets its own rigid component with the same properties as they were for MeshRoot rigid component. They get this mesh object type, obviously because they are just regular meshes. As you can see, they're all sleeping because I set sleeping simulation type for original MeshRoot object type here. Also, later I will show you if you want to create connected structures. There's also should be used with MeshRoot object type and connectivity and any other component. I will show you later how to use them in another tutorial about connectivity component. For now, just showing you that this is how and when should be used MeshRoot object type. Let me just move one of them. I can see every fragment simulates separately. So this is not demolition. Demolition is when one object turns to another object or objects. This time it was just a bunch of fragments. Every fragment already had its own rigid component. They just simulate separately, that's all. Another object type here is connected cluster. It has the same structure as a MeshRoot object, so it also pre-fragmented here. And again, all fragments should be just one layer children of this root with rigid with connected cluster object type. No deep children, just one layer of children. But this time, if I initialize this object, every fragment again gets its own mesh collider. But this time there's only one rigid component, and it is on this rigid connected cluster on the root. Not every fragment has a rigid component, but actual root get this rigid component. So whole object simulates as one object. But as you can see, if I will initialize mesh, it gets this one convex collider. So if I will simulate it, it will be pushed from these edges because there is no way to simulate dynamic concave meshes. But this kind of object, as you can see, since every fragment has its own collider, all this object will be simulated as one concave object. Also, another benefit of using connected cluster is that, as you can see, there are these blue lines. Maybe it's hard to see them. So they show you connections amongst all these fragments. So if, let's say, you will shut this column at the middle or hit it with something, it will be demolished around this point. Some of the fragments will get rigid component with mesh object type and will be simulated separately. But upper part, since it will stay connected with each other, it will be turned to one small connected cluster, and bottom part also will be turned into one small connected part. So let me show you right now. I will just drop it. It was demolished around this collision point here. So some of the fragments here, they get their own rigid component with mesh object type and its own rigid body. But this upper part, you can see it stayed as one. You can see this one is still connected cluster. It holds this group of objects. It get its own rigid component with connected cluster with its own rigid body. I will select it here. So here you can see this new, smaller connected cluster. So it will be simulated as one solid object, and it also may be demolished on collision. Here you can see it was also demolished, and here we have this even lesser connected cluster. So this is how connected cluster works. So in this way you can just gradually demolish them and to make them smaller and smaller, creating even less connected cluster. And the next object type here is nested cluster. So this object type, let me show you its hierarchy. So here you can see there are the same fragments, but this time I reorganized them. As you can see, there is this a bunch of fragments at the middle here, at this area. So I have them as children of this main nested cluster root. But also I have these two nests here. So one nest is for the top, so this group of fragments, and then there is another nest for this bottom part. So I basically have just one group here, and a bunch of small fragments here. So this is where you can create all this nest to create all this deep children structure. And as you can see, every nest is just an empty root. There are no any components here, just transform. So this is my top part, and here you can see it also has a bunch of mesh fragments at the middle, and it also has another couple of nests, another top part and another bottom part here, and bottom part just has one layer of mesh children. So all bottom parts just children of one nest. So this is just example how you can create all these nests. And the reason why you should do this is when you want to demolish your object not around collision point, but in specific order. So when this object will be demolished first time, it will demolish it to these two nests. Every nest will get its own rigid component with nested cluster, and all these regular mesh fragments will get rigid with mesh object type. So let me just show you. Also, you should know that you should define here this depth in limitation, because it will define how many times object can be demolished deeper and deeper. So I will set it 3 this time. So now let me start play mode, initialize. Again, now it will simulate as one object. So if you do not demolish connected cluster or nested cluster, there is no difference between them. They all will be simulated as one object. But if you want to demolish your object in specific way, in specific order, and exactly to kind of group of fragments which you want the object to be demolished, this is where you can use nested clusters. So if I will just click here, demolish this time, again, a bunch of fragments here and two nests here and here. So I'm demolishing it. Oh, it's actually that wasn't even crumbling. So let me, instead of just clicking demolish, let me just move it maybe upper so it will fall down like this, and initialize now. So here you can see it was demolished, and here's my, again, top nested cluster which was demolished to, and bottom, and a bunch of fragments here like this one. You can see it has its own rigid with mesh object type. So it was demolished exactly as I designed to be demolished at the middle, to a bunch of little fragments here and two big pieces here. But now all these nested clusters also will be demolished further when, let me show you how, when it will fall. So let me hide this dude. So here's my upper nested cluster. Here you can see it was it hit the ground here, and again it was separated to two new nests, this nest top 2 and nest top 1 groups. And my bottom nest also was demolished, two regular fragments, because there were no any deeper nests, so it was demolished just to regular fragments. And playing with this in limitation, as you can see, they were very fragile, but you can play with solidity to make them less fragile here. So that was nested cluster, and final object type is skinned object, and it doesn't define any simulation properties here. It just defines this object as skinned mesh. So if you will slice it or demolish it, it will know how to handle this properly. Just let me show you. So this is my animated skinned mesh. If I will click demolish, it fragments to this fragments. Well, and again, I will show later how to use all these demolitions deeper in detail with every property here. So, but for now, just a quick overview of different object types. Another property here is simulation type, and the simulation type defines how objects will be simulated. So here's my simple setup. Every object has its own simulation type. As you can see, first one is dynamic object, and these are the objects that will be affected by gravity immediately. they will start fall down and they will interact with the rest of object types. Second one is sleeping, and this is another type of dynamic object, but they freeze into the air, in the air. They are not affected by gravity immediately, so they will be affected after slightest touch with dynamic object or kinematic object. So just if you will just move them a little bit, they will become full dynamic object. So let me show you. Here you can see after slightest touch, this sleeping object was turned to dynamic object here. And this type object type here is inactive, and this is also kind of dynamic object. It also freezes in air like sleeping object, but sleeping object turns into dynamic after slightest touch, while inactive object stays inactive after collision. So you can see it was pushed, and while this sphere was on top of this inactive object, it was pushed, but after sphere fall down, it just fixed its position. So inactive object is not affected by gravity, and it also has now any velocity. Even if you will hit with something, it will be pushed, but it will stay in the air. There's a whole group of properties for activation of inactive objects. So sleeping objects can be activated just by touch, while inactive objects can be activated by all these properties. Later I will show you in a special video how to convert inactive and kinematic objects into dynamic. So for now, just remember that inactive objects are objects kind of object that can be pushed by dynamic, but they will stay in the air and will not be affected by gravity and other forces. Another time, one more time to show you. Here you can see it fixed in the air. And another type of objects here is static. And as you can see, let me disable play mode. So if you want to use original mesh as collider, this is the only way to use it is to use static meshes, because if we will set here, let's say, kinematic object type, let me select now. It's not visible here, but let me fold the sphere. Here you can see it fall to this edge here, but it wasn't fall inside this hole here, because kinematic objects and dynamic objects can use only convex. You see here, I'm using this mesh collider here, but it has this convex toggle enabled, and it means that it wraps such objects into this convex collider. So it's possible only to use this convex hole. You can't use actual mesh as collider, so something will fall into this ground. And to use actual mesh, the only way is to use this static simulation type. You can see in this way, my sphere falls inside this hole. But the disadvantage of using static meshes is that this kind of objects should not be moved, even though you may kind of move it and it will kind of push, but it's not supposed to be used in this way, because you can see in this case it doesn't work all the time. Sometimes it works, sometimes it's not, because collision detection for static objects with dynamic objects is not work as good as this another kinematic object type. This is a simulation type which you need to use for object that also will not be affected by gravity as static object, and by any other kind of objects. As you saw, I can't use my, let's say, dynamic object to push the static object, so it's fixed in space. And just like kinematic objects also cannot be pushed by gravity, by other dynamic object, but kinematic object can push other object. As you can see, collision works great. So you can see I can, like, there's perfect collision detection. It responds to all collision completely, not like this static object type. You can see kind of sometimes it pushes, sometimes not. So just remember, if you want to use actual mesh of some kind of ground object, something static that is not supposed to be moved, then you can use a static simulation type. But if you have something animated or maybe it will be moved sometime later your game, then you should use kinematic object type. Also, kinematic object type, just like inactive object type, also can be activated using the same properties here. So here you can see that there's a special button here. I can, let's say, select this inactive type and just using this button activate it here. And the same I can do for kinematic objects. But static objects, it's always should be static. It should not be moved and always stay the same. But with static object, you can use actual mesh, because if you will set here kinematic or dynamic object, then it will create convex hull collider, and you will not be able to use all this concave area inside this object. So that was simulation types. Now I want to show you how to use these physics properties here, and first group of properties here is this material properties. As you can see, there is this drop down of presets here. So if you do not want to manually apply properties like mass, friction, bounciness to your object, you can just pick one of these material presets here, and it will apply all these hard-coded properties to your object. So here's my concrete column. This column is identical to the first one, but its material type is heavy metal. This one is ice. And for this, I used my custom physics material here. You can see this rubber. So I created it as asset here, set here my own custom properties, and applied it here. So this is how you can use your own custom physics for physics material for your object. Instead of using these presets, you can define your own physics material here, and it will be used instead of one of the presets here. So now let me start play mode. You can see that it creates this physics material here according to this preset here, and then applies it to mesh collider here. And here's my mass of this column here. As you can see, it's approximately 10, but because this is concrete, if I will select this one, you can see it's 36. So it automatically calculate the mass of the subject accordingly to its density. Because it's heavy metal, it's higher than the concrete. And this one is ice. As you can see, it's less than concrete. It's 3. And for this one, it was used this concrete material preset to apply mass, but physics material actually was used from this asset here. So just remember this and pick one of these presets accordingly to something similar to what your custom presets object should be. Now let me start demolishing this object. So here's my concrete. You can see how friction works for this one. And this time I'm dropping this metal column. As you can see, it not demolished. So this is because heavy metals cannot be demolished, as well as light metals. And you can change this. I will show you a bit later how to do this. So by default, any metal objects cannot be demolished. This one is ice. And here you can see its friction. As you can see, it works as ice. Now let me demolish my rubber object here. Here you can see, because of the high bounciness, it starts bouncing everywhere. And this is how you can change this material presets. Here you can have this manager component. This is basically just object with Rayfire main component. And there'll be another tutorial about all these properties, but since I am talking about physics material, I should mention that all these presets, you can find them here in materials properties here. And here you can pick any of these materials from the preset here. And here you can change these hard-coded properties. So if you want to adjust them, this is where you can do this. Light metal, you can see when you select them, they all change their properties here. Also, there's this demolishable toggle. So again, you can pick heavy metal. You can see it's not demolishable. So you can change this here. You can make it demolishable by enabling it here, and change all this friction, bounce properties, density, drag, angular drag. Also, you can define the same custom material here. Instead of applying it to every object, every rigid component, you can just define it here. So it will be used for all materials when you will pick them here in the rigid preset list. Next property here is mass by, and there are three ways to define mass for your object. It's by material density accordingly to this material preset here. Here's my simple setup. For this column, I'm using material density property, as well as for these two, but these two are less in size. And so this is concrete. Second column is also concrete, but third column is heavy metal. So when I start play mode, you can see for this column, its mass right now is approximately 10. For this one, it's 2 because it's much less in size and because it has the same material. But third one is heavy metal and its mass is bigger. Again, because all three columns here, they're using this material by density. And density is different for all material in this material preset list. This one is has material, mass by set to mass property here. And when you set it to mass property, you can see when you set it here, it reveals this other property here. So basically, it just takes this value from here and applies it to rigid body. So in this way, you can define exactly which mass you want your object to have. And third one is set to rigid body component. So as you can see, this object already has its own rigid body component, and I set here mass 99. So again, this is how you can use not only your specific mass, just like with this object, but you can actually use your rigid body, because there's a way to use rigid body with all these properties, but mass will be applied accordingly to this mass by property. So you can use your own custom rigid body already applied to your object, but if your mass by set to one of these two properties, mass on rigid body will be overwritten. And if you want to use your specific rigid body with already predefined mass, then you need to select your rigid body component here. So this is how this mass by property works. Next property here is this collider type, and it's pretty straightforward property. There's mesh, box, sphere, and none types. So first one is mesh. It means that for dynamic object that will create convex hull for this mesh using this mesh. This time for this one, this is set to box, this one sphere, and this one is set to none here. So as you can see, I added these three colliders here, a couple of box collider and one capsule collider. So in case you have some kind of combination of colliders on your object, you can set here none. So plugin will use your colliders instead of adding new colliders like this one. You can see there's this convex collider, this one just a box, and for this one it created sphere collider. So that was collider properties. Another important property in physics simulation properties here is this ignore near toggle, and it allows you to disable collision between two close colliders. Sometimes you may have objects that are overlapped with each other, like this top table part and this leg. As you can see, it overlaps here. Also, there is this plank. As you can see, it also overlaps with this leg at this place. So, of course, I did this intentional just to show you when you need to use this property. So let's say I will fragment the setup using flat hierarchy. So all the fragments will be under one root. So this is my fragments here. Just root, a bunch of fragments. And I will add rigid component this time with MeshRoot object type. So every fragment will get its own collider and rigid body. Set it to its start and maybe an active type, so it will be easier to see. So right now my ignore near property is disabled. And if I start simulation and right now objects are sleeping, so I just need to kind of push them a little bit. So here you can see just when I slightly touched one of the fragments, they all started simulates and all detected collision with all these overlapped fragments, and they pushed each other from this shared space. So this is how, this is basically what you will get if you have overlapped fragments in your setup. And usually when someone creating models, people do not consider that these models will be simulated. So they don't care much. They may have these overlapped fragments all over the mesh. Of course, it's better to avoid this. But in case you already have this mesh and you have to deal with it, this is how you can fix it. You just need to enable this ignore near property here. And what it will do, it will check for bounding box overlap for every fragment. And it will disable collision to all fragments around this fragment. So let's say for this object, let's say this one, maybe this one, you can see there's this fragment on the left. So if I will move it, there will not be any collision here because there is no collision between this fragment and this, and between this one. As you can see, it also does not react to this. But if I will move this fragment here, you can see it start colliding with the rest of the fragments. So it doesn't collide only with only with fragments around it. And the same it do for every fragment here. You can see this one doesn't collide with fragment on the right and fragment on the left, but collide with the rest of the mesh. Of course, simulation quality will be less in this case, but in some case you just have to deal with this kind of meshes. You can't fix them, or you don't want to fix them, so you can just use this ignore near property here on the MeshRoot here. It works only for MeshRoot and for connected and nested clusters. And all the fragments, all the children under this object with this rigid component will be checked for overlapping areas, and collision will be disabled for all colliders around every collider. So this is how ignore near property works. And last properties here are these other properties. First one is use gravity, pretty straightforward property. If you disable use gravity, object will not be affected by gravity. It will just float in the air. And if you want to create better quality for simulation, you can slightly increase solver iterations. If quality of simulation is not very important for you, you can slightly decrease solver iterations property. Sleeping threshold defines how quickly your object and fragment will get to rest and again turn to sleeping in case they were dynamic. And dampening is kind of multiplier for inherited velocity for fragments of object. So right now its default value is 0.7, which means that if something you smash over the ground, let's say, velocity of fragments will be inherited from the original object, but then multiplied to 0.7. So they will be slightly slower than the original object. So this is where you can completely decrease their velocity or maybe even exaggerate if you want to get some kind of explosive demolition. So fragments will be exploded all over the place after collision with something. So this is a property you can tweak.